Okay, so this video is about using Simpson's rule to approximate an integral. So really quickly, Simpson's rule is just like our Riemann sum approximations, like our trapezoid approximations, but better in most cases. So what Simpson's rule does is, just like all approximations, you'll take an integral from a to b, and you'll partition it into so many subintervals, and you can use left bound, right bound, midpoint Riemann sums, or you can use the trapezoid rule. And let me make a better picture here so we can look at it a little better. So with trapezoid rule, what is being done is each partition we're forming a trapezoid. And if you can see what's happening here is the top of these intervals are being approximated with a line, and thus a trapezoid. Simpson's rule is going to take the tops, and I'm going to go over here and make them parabolas instead of lines. So there'll be some curve to them, and it will follow the graph a little bit more closely. So without going into how it's derived, here is Simpson's rule. So a few things you should notice about this is it's just this single constant times the values of the functions at each subinterval. But notice the coefficients. For the first one, x sub 0, the one on the left, it's 1. So this would be x sub 0. The last one is x sub n. And then all the ones in between, x sub 1, x sub 2, are going to alternate between 4, 2, 4, 2, etc. So basically, it's more or less just a plug and chug thing. It's pretty easy. It's a complicated formula, but it's pretty easy. So we're going to do this example. We're going to approximate this integral using Simpson's rule and 4 subintervals. So we're going from 0 to 2. So if we want to partition this into 4 subintervals, where the middle is a 1, and then partition that again, we have a 0.5 here and a 1.5 here. So x sub 0 is 0, x sub 1 is 0.5, and so on and so on and so on. So we can approximate this integral by using the formula, which is b minus a over 3n. So b is 2, a is 0, over 3n. N is the number of subintervals, 4, and now multiplied by f of x sub 0. That's f of 0. Plus, we're going to start with 4 and alternate between 4 and 2. So 4 times f of 0.5 plus 2 times f of 1. So I'm just following these in order here. Plus 4 times f of 1.5. And then finally, when you get to the last one, that's just 1 times that. So let me move this out of the way. Bad planning as usual. So plus 1 times f of 2. So it's pretty easy. All we're going to do is plug in. This is 1/2. F of 0 is the square root of 1 plus 0. F of 0.5 is the square root of 1 plus 0.5 squared. So I have my calculator set up for you. So I'm just going to make it quick. The square root, I plugged in the square root of 1 plus x cubed in there. So I'm just going to hit second calc value at 0.5, and that will give me that answer. So 1.0607. And then plus 2 times f of 1, which is the square root of 1 plus 1 over the square root of 2, which is about 1.14. But let's just plug in 1.4142, and then plus 4 times f of 1.5. So now I'll just hit 1.5 and figure out what the value is. 2.0916. And finally, f of 2, which is the square root of 1 plus, this is easy, 2 cubed, this is 3, right? The square root of 1 plus 8. And now we're going to calculate that. So I'm going to type it in on the calculator. So I will hit, you can't see it because I need to see all this stuff. So it's 0.5 times 1 plus 4 times 1.0651, I think that says, plus 2 times 1.4142 plus 4 times 2.0916 plus 3. So hopefully I could read all my handwriting and I plugged it in right. I just typed it on the calculator. And you hit enter. Let me just make sure that I plugged the 1/2 in before. I forget. Yeah, that's the 1/2 in front of it. So this should come out to be the final answer of 9.7276. That's all there is to it. 9.7276. Now, don't go anywhere. This should be a very good approximation. So let's take the integral. It's already in there from 0 to 2 and see what we get. So here's the graph. Take the integral from 0 to 2. And, oh, it's not right. So something went wrong, and I should have checked the integral before. So I'm checking my work. So that's it. This is a really good video on the importance of checking, which it wasn't meant to be, but it is. So I'm checking my work for square root of 9 is 3. Everything looks pretty good to me, and I just can't see it. So here's what I'm going to do. I'm going to stop this video. I'm going to try not to delete it because it took me too much time. And I'm going to find the mistake, and I'm going to issue the nice correction video, hopefully very shortly. So thank you for watching, and I'll see you soon.